Greetings. We're Oilfield Innovations, and we're developing a new 60 millimeter or 2 3/8 inch OD cutter for our downhole tubing disposal product. Prior to explaining the cutter, we will explain the ultimate purpose of the tool, which is splitting or shredding tubing so that it can be compacted and disposed of downhole. We're experts with over 30 years of experience in well operations, and we've patented and tested the worst case downhole tubing disposal situation. We verified our patented method of downhole tubing disposal by crushing and compacting 2 3/8 inch API tubing within horizontal 5.5 inch API casing using equipment you can find at your local garden center. Here we show 5.5 inch casing lying horizontally on the ground. The process of verifying our patented method consisted of splitting the tubing, inserting the split tubing into the horizontal casing, then placing a piston and a cap on one end of the casing. We then use an ordinary garden pressure washer to pressurize the casing, push the piston, and compact the split tubing. With a cap holding the split tubing on the other end, we used water to pressurize the piston and crush the tubing using around 3,500 psi or 240 bars of pressure, which was the garden pressure washer's maximum rating. Compacting split tubing takes significantly less pressure because you only need to drive one piece of tubing into a lower split piece of tubing. But our garden power washer could not deliver the volume of oil field pumps, so we let it take its time until it reached the maximum pressure, and then we stopped the process. We then removed the cap holding the tubing and pushed the tubing from the casing by pumping against the crushing piston with the power washer. We used a piece of pipe as a piston and cement wiper plugs as seals behind the piston. We experimented with various tubing splits and determined that after the first split, the compression ratio with a high friction factor of dry crushing horizontally was about 50% compaction ratio using the garden power washer. As the tubing often expanded after being ejected from the casing, we decided to cut a window in one of the specimens to see how it would look downhole within a well. Using a saw, I cut a window in the casing. As you can see, using gardening tools, we verified our patented method by dry crushing the tubing horizontally, which is obviously the worst case, since compaction will almost always be aided by gravity and an inclined well bore, with well fluids lubricating the compaction process. While alleged experts intent on using or selling the services of a drilling rig may criticize or question our process, you don't have to be a rocket scientist to understand that if you can compact API tubulars in your backyard with gardening tools, it can be more easily accomplished with proper oilfield equipment. Now that you know how easy API tubulars can be compacted after they are split, let's look how we split or shred the tubing or casing downhole. This is our patented skate vertical cutter, which can be lowered into the well, extended, and lifted up and down to split or shred the tubing prior to retracting the cutter and hoisting it out of the well. At Oilfield Innovations, we use state-of-the-art software to design our patents and tools in a virtual 3D environment. Virtually modeling the tools allows us to see the end product before it is built. It also allows us to run stress analysis to ensure sturdy and robust tools. You can easily see functionality. For example, you can see that pushing the central piston down extends the tool, and pushing the central piston upwards retracts the tool. Our vertical cutter is designed to be stacked and aligned so that one of these tools can be stacked on top of another, with a central piston extending between the tools. Pushing the top vertical cutter central piston downwards actuates the vertical cutter, and any vertical cutters engaged to the bottom of the upper vertical cutter, whereby when the bottom vertical cutter's central piston is pushed upwards, it pushes and retracts any vertical cutters above it. We use various high-resolution graphics packages together with Autodesk's state-of-the-art engineering product design suite to model every component of our tool in machining tolerances in 3 dimensions. This 60 millimeter tool is designed to be run on slick lines so it can be extended and hoisted between selected depths to roll cutting wheels capable of cutting any API grade tubular. Now that we've looked at the external part, let's look a little bit more at the internal parts of our cutter. Changing a few settings, we can look inside the tool to see how it works. As you can see, it's critical to fit the various bolts and pins between the relatively large 3 cutting wheels. The pins act as axles for the upper arm and the cutting wheel, with an intermediate securing bolt. Independent larger and smaller diameter actuation shafts within the cutter allow makeup of the internal shafts prior to making up the larger diameter threads of the housing. The lower, smaller diameter actuation shaft slots into the larger diameter skate actuation shaft to allow independent rotation and makeup of the internal series. The lower arm of the skate is secured between the skate actuation shaft and the cutter's housing, while the upper skate arm is secured between the skate actuation shaft and the skate. An upper actuation shaft from either the spring drive actuator or another vertical cutter screws into the skate actuation shaft, which is pushed downwards to actuate the vertical cutter and engage the cutting wheels to the tubing or casing. During assembly, the skate shaft and upper arm are inserted into the housing prior to extending the upper arm to attach the skate and lower arm, which is secured to the housing via a bolt. With the skate extended, the lower actuation shaft extends from the housing for connection to the next part of the assembly and can be rotated independently via a slot connection. Underneath the high-resolution model are layouts with tolerances and dimensions for the entire skate vertical cutter assembly to accelerate the development process. Here we have modeled a third-party tool that can be used to actuate our spring drive system downhole. Compression springs within our spring drive actuator are compressed by the third-party tool so that the skate cutter is extended by a constant controlled spring force. Let's look at the springs of the actuator, which is shown here in red. When our cutter reaches the desired depth, the third-party tool compresses the springs. Like all slickline tools, we use a shear pin which is severed by the third-party tool to release the compressed springs and extend the cutting skate. A second third-party tool is used to retract the cutter skate after a specified time by recompressing springs until the second shear pin is severed. The weight of the bottom hole assembly can then be used to retract the skates and relax the compressed springs for easy disassembly. Hoisting the bottom hole assembly up and down rolls the cutting wheels to cut the tubing or casing. The cutting depth can be controlled by the diameter of the cutting wheels. The skate can use small diameter cutting wheels, shown in magenta, or larger diameter cutting wheels, shown in green, up to a maximum diameter cutting wheel, shown here in yellow. We use dynamic modeling software so that we can see exactly how parts move. Even layout models can be moved to test functionality. As you can see, we can automatically or manually simulate movement. Using the dynamic modeling, we have designed a swivel connection that can be used to orientate stacked skate cutters and ball bearing rollers that can be used to let the string rest on the lower side of the well so as to orientate the cutters if multiple cutting runs are required. Conventional go-devils can be used on the ends of the bottom hole assembly, or we can use our orientation roller swivel between skate cutters to orientate different skates and provide ball bearings to support the skates when they are hoisted during cutting. You can see the ball bearing rollers here just above the retraction crossover. Conventional third-party tools can be used to actuate the skate, and the second tool can be used on a timer to deactivate the skate after a specified cutting period. Actuation pushes the central shaft downwards. Deactivating our vertical cutter and retracting the skate simply requires pushing and compressing the actuation springs to retract the skate and shear the release pin so that both the springs and the tool string weight can be used to retract the cutter skate and pull the slickline tool string from the hole. Ultimately, the purpose of simulation is to provide robust machining drawings so as to make the tooling necessary for low-cost downhole tubing disposal and well abandonment. While we have blurred the dimensions for proprietary reasons, the simulations which you have witnessed in this video have all been incorporated via state-of-the-art software into these drawings. The skate activation piston is shown here. The skate arms are shown here. This is the skate and the opposite skate clamp. This is the skate and the skate clamp together. The lower central actuation piston. the cutting wheel, and the axles, and the bolts, and the lock washer associated with clamping the skate together. We are a small company, but hopefully we have made it clear that Oilfield Innovations has the necessary technology and experience to deliver. Our employees are experienced professionals. We're fully versed in all existing technology and have patented simple methods and technologies for reducing the cost of disposing of tubing and casing downhole during, for example, suspension or abandonment. If you are a service company who wants to be part of the technological revolution, or if you're an oil and gas operator that wants to reduce the cost of plugging, suspending, and abandoning wells, we have the answers, and we can show that the cost of developing our technology can be recovered within the first few wells, regardless of whether you're an operator or a service company. Thank you for your kind attention.